Welcome back to Module 1 Algebra Foundations. So far, we have explored real numbers and laws of exponents. Today, we move deeper into algebra. We are going to unlock the structure of polynomials. And by the end of this lesson, you will not just factor polynomials, you will understand them. Let's start the lesson. A polynomial is an algebraic expression made of terms. Each term has a coefficient and a power of a variable. See the example here. 3x power 4 minus 2x square plus 7x minus 5. The x power 4 is the highest power here. The highest exponent tells us the degree. So this is a degree 4 polynomial. A degree is equal to the highest power. So here x power 4. 4 is the highest power here. And a leading coefficient is equal to the coefficient of highest degree term. So here the leading coefficient is 3 because the x power 4 is the highest degree and 3 is the coefficient of x power 4. See, the degrees tells us the shape of the graph. Let's start with a simple example. X square minus 5x plus 6. This is a quadratic equation. Here we ask two questions. What are the two numbers which we multiply to get 6? And the same number if we add, we need to get minus 5. The answer is minus 2 and minus 3. Here, if we multiply minus 2 and minus 3, we get positive 6. And if we add minus 2 and minus 3, we get minus 5. So we can write the quadratic equation into the factor of two numbers. So x minus 2 and x minus 3. This is a basic factoring. Another example of factoring is always look for a common factor first. See this example. 6x cube plus 9x square. What is the common factor here? 3x square is the common factor. We can take out 3x square from 6x cube and 9x square. Then we can write it in the factor form. So 3x square take out from the 6x cube. Then 2x left there. Then 3x square take out from 9x square. Then what is left there is 3. So we can write 3x square times 2x plus 3. This is the factored form. Always take out the greatest common factor first. This is the first rule of factoring. Now let's move to higher degree polynomials. See the example here. X cube minus 3x square minus 4x plus 12. When we see 4 terms, we try grouping. The group power equation. X cube and 3x square. We can consider it as the first group because we can take out x square from each terms. And 4x and 12. Here 4 is a common factor. We can take 4 out. So we can group like this. X cube minus 3x square in first group minus 4x minus 12. Why minus 12? Because when we introduce a bracket after the minus sign, we need to reverse the sign inside. Because when we open the bracket, we will multiply the minus sign with each term. So we will get minus 4x plus 12. Let's continue. Factor each group. So x square take out from the first group and 4 take out from the second group. So it will be x square times x minus 3 minus 4 times x minus 3. See, x minus 3 is a common term on the both sides. So take out x minus 3, then we will get x minus 3 times x square minus 4. But wait, is difference of squares. So we have equation a square minus b square equal to a minus b into a plus b. same thing we apply here for x square minus 4. 4 is square of 2, so 2 square is 4. So we can write our equation x minus 3 times x minus 2 times x plus 2. See, this is a higher degree polynomial factoring. Let's see one specific example of difference of square factoring technique. Example is x power 4 minus 16. Recognize 16 is equal to 4 square. So rewrite the equation x power 4 minus 4 square. So factor x power 4 minus 4 square using difference of square. So x square minus 4 times x square plus 4. So now we can again factor x square minus 4 using difference of square equation, because x square minus 4 is 2 square. So we factor again. So we get x minus 2 times x plus 2 times x square plus 4. The x square plus 4, we cannot apply difference of square equation there because it's not different. It's x square plus 4. So this is the maximum factoring we can do. Factoring continues until no further factoring is possible. Here no further factoring is possible. So this is the factored final form. Factor theorem says if f of a is equal to 0, then x minus a is a factor. This connects factoring to function roots. Factoring helps us find where the graph crosses the x-axis. Very important line is that factors reveals the roots and roots reveals the graph behavior, and graph behavior leads to calculus. Let's connect to the graph. See the example x minus 3 times x minus 2 times x plus 2. These are the factored form of a polynomial equation. Let's see, the roots are x equal to 3 and x equal to 2 and x equal to minus 2. So these 3 points, the graph crosses the x-axis. So these are the x-intercepts. So this is why factoring is powerful. Today we have learned what is a degree of a polynomial and what's the leading coefficient of a polynomial. Then GCF factoring, greatest common factor factoring, then factoring by grouping, factoring using difference of squares, then higher degree factoring of a polynomial, a link between factors and roots. See, factoring is not memorizing something. It is a pattern identification. Now, factor the following examples by yourself. Follow the steps, look for GCF, use grouping methods, apply special identities like difference of square. Keep trying. If you can factor confidently, you are mastering algebra structure. Strong algebra structure builds you strong calculus understanding. I will see you in the next lesson.